Hi, this is Don Gutzmer from WEST SYSTEM Epoxy. Today I brought in this 1980 Chris Craft Scorpion 230. It's a fiberglass boat we bought a while back as a project. So far I replaced the transom, but today I'm going to tackle the stringers that need to be replaced because it's got a lot of rotted wood. So let's start on the project. As you can see, we've removed the cockpit sole. It was rotted, so it had a lot of areas that the integrity of the wood was pretty much gone. So we removed all that. Now we exposed the stringers, and as you can see, we've got some deterioration of the wood. This is actually lumber here. Kind of looks similar to like a Douglas fir, just a soft wood. Actually, the glass is still there, but the integrity of the wood has been jeopardized with water intrusion. And you can kind of see back here on this frame is where water came in through some of these drain holes and has worked its way in here. And this looks like it's a plywood. You can see how it's just deteriorated, coming apart. So one quick method to know if you're having issues with like delamination or rotted wood is to actually do what's called a tap test. So either take a hammer, or what I have right here is a heavyweight washer. So as I tap the surfaces for something that is very solid, that's got good integrity of like the plywood or this lumber here, you should hear a very high-pitched noise. So I can see up forward, it kind of looks like the fiberglass and the wood looks quite solid up there. So I'll hit that location and you can kind of sound what it sounds like. So now I'll come back here and hit here, and you can hear a lot duller noise. That impact that I hit the surface doesn't transfer through, and it doesn't have a high-pitched ring. You can actually see the stringer flexing as I hit it. So that's one quick and easy method just to sound the surface, to get an idea of the locations that may be an issue that you may want to address. We're going to replace this stringer all the way up to this bulkhead, this frame right here. We can see that this plywood, this frame is deteriorated, and so we'll replace that. So we'll just do these two areas to start. But before I start coming in here and cutting the fiberglass away to get to the wood, one thing that we're going to do to make it easy on myself is we're going to build a jig. So we have the jig built now. It will ensure the correct placement of the new stringer and the frame. This is built from 2x4s, so this was all screwed together. It can be actually removed, just lifted out and removed. So once it's down in position, you just take clamps and clamp it to the stringers. So the 2x4s were sitting on top of the frames as a reference for height. So now I could either take a clamp or a screw to screw to it to hold the new stringer in position. So I can put it in the exact same location. Same thing's true for this frame back here. Now I can fasten that new frame to the jig. Once it's all glassed in, I can take the fasteners back out, remove the jig, and everything's in the exact same location that it was before. So this is just a very easy thing to build. It's a bit overkill for this project, but for bigger projects, this is going to save you a lot of headache, and it's very effective. Before we get started, I'm going to put on my PPE, including a respirator. I used a vibrating multi-tool to cut the old stringer out. I definitely don't want to cut into the hull, so I'm going to hold the blade parallel to the surface of the hull and cut the tabbing about 1/8 to 1/4 inch above the surface. Then I'll grind the tabbing flush to the hull, and I'll repeat the process on the frame. For this project, rather than removing all the rotted stringers at once, we're replacing the structure a couple pieces at a time. This will minimize the potential for hull movement during the removal and reinstallation process. If I were removing any more structure than just the stringer and the frame, or if it was a larger boat, I would want to support the outside of the hull with blocking to make sure it does not move. With all the grinding complete, I vacuumed off the surface to remove the dust and debris. The one thing I didn't do is grind this stringer right here, because there's no reason for it, because this is going to be removed because it is rotted. So when I bond in the new frame, I'm not actually going to tab onto this existing stringer. So now we're to the stage of creating the template for this new frame. So I have some thin cardboard that I'm going to use to create the template. I'll just cut it and get it into position and tape it with some duct tape. From there, I can take it to my new piece of 3/4 inch marine grade plywood, trace it out and cut it, and then fit it to get it close. Even if there is a little bit of gaps, that's completely fine to take that up with some thickened epoxy. The original pieces may have had gaps between them and the hull to avoid creating a hard spot against the hull bottom. By using thickened epoxy, the load is distributed evenly into the hull, preventing hard spots. And from there, we'll pull it back out and router the top edge. Then we should be good. So this is just dry fit into positions. It's not tight to get it in. I actually have to remove the jig and lift it up to get it into position, but it's locked in, clamped all in nicely. The other thing that I ended up cutting is the new wood stringer. So this stringer is cut to length, and I routed the top edge so the glass can conform around the top edge and not try to go around a tight corner. I've saved a section of laminate from the rotted stringer to use as a gauge for how thick the new laminate should be. I measured it at a thickness of 1/100,000th of an inch, which means I'll need 3 layers of 17-ounce fiberglass. I chose to laminate the stringer and frame outside the boat to make things a lot easier on myself. I started to apply a coat of WEST System 105 epoxy resin mixed with 206 slow hardener to the bare wood. This allows the epoxy to soak into the porous wood to ensure a good bond with the fiberglass. I laid the first layer of 17-ounce fiberglass over the stringer and wet it out with the same epoxy mixture. I'll cut the fiberglass a little long to ensure it would continue all the way to the bottom edge of the stringer. I'll trim the extra off once the epoxy cures. Once the fibers have been wet out, turning the fiberglass translucent, I used my spreader to apply moderate pressure to the fiberglass to make sure it was making good contact with the wood. Then I re-wet the surface with epoxy before adding my second layer of fiberglass. I repeated the process until I had all 3 layers on the stringer. Because I applied my layers of fiberglass to the stringer while it was outside of the boat, I have to let the epoxy cure before moving into the boat and tabbing it to the hull. By putting a strip of release fabric on the wet laminate where the tabbing would eventually go, I don't have to sand the surface before bonding later. Once the epoxy is cured and I'm ready to tab the stringer to the hull, I can remove the release fabric, leaving behind a clean, textured, blush-free surface ready for bonding. For the frame, we followed the same process, again, rounding over the top edge, mounting it between the uprights and applying 3 layers of 17-ounce fiberglass. All right, I just stepped back into the boat. Now that I have the frame here and stringer all glass and cured, I want to dry fit those, try to get them in position to make sure they go in easily, that everything lines up, the stringers line up where they need to. I'm not fighting to get them into position. So the other thing I want to do too before I end up glassing this frame all in, there is limber holes. So I want to mark those. There was one located right at the bottom corner on each side of this frame, here and here. And at the bottom here, I want to kind of cut that out so if any water gets down here, it can drain out to the back of the boat. All right, now I'm going to pull the frame out and we'll get that cut. On the end grain from each of the limber holes, I applied a coat of unthickened epoxy so the epoxy can soak into the wood, and then I applied a thickened coat of epoxy over the top. This light buildup will seal the wood in a single coat and ensure the wood does not become saturated and rot like the previous frame. I vacuumed the surface once again to remove any dust or debris that I might have tracked into the boat during the test fitting. So now that we have it all cleared out, we want to ensure that the surface is clean. Using solvent like acetone or lacquer thinner is perfectly fine to use. Say if it was contaminated with some like oil or grease because you're down in the bilge or near the motor, this is going to help remove it a lot more effectively than it would be just to grind the surface and vacuum it back off. I always advise using plain white paper towels. Cheap plain white paper towels are the best because they don't have any additives in them. You also don't want to use something like a rag or a cloth that might have gone through the laundry or has detergent on it. The solvent can attack contaminants in the rag and leave them on the surface. So what I usually do is I'll get the surface fairly wet with solvent like acetone here, and I'll gently wipe the surface with a paper towel before it evaporates away. Don't wipe too aggressively or you're just going to have residuals of the paper towel left on the surface. See how it's kind of dirty? You just want to do that a couple times until clean. Now that the hull is prepared, we're ready for epoxy. We can remove the release fabric that's been keeping the tabbing surfaces clean. I coated the edges of the stringer and the frame with unthickened epoxy so it could soak into the porous wood. I also wet out the hull where the stringer and frame would go. Next, I thickened my epoxy with 406 colloidal silica. This is a great all-purpose filler that will leave a fairly smooth surface once cured. I liberally apply this to the hull where the stringer and frame would go to fill any gaps. As I push the frame and the stringer into the thickened epoxy, I watch to make sure I have good amount of epoxy squeeze out along the whole length. This is a good indication that there aren't any air voids and the epoxy is fully in contact with the wood. I reinstall the jig. It forces the stringer and frame into the proper alignment, and then I secure them to the jig with a couple of screws. I mixed up another batch of 105 epoxy resin, 206 slow hardener, and 406 colloidal silica. I built up a fillet where the stringer and frame transition to the hull. This buildup allows for a gradual transition from the tabbing onto the hull. We often recommend our mixing sticks for creating fillets, but in this case our mixing sticks are too small of a radius. So I took a paint stick and rounded off the corners instead. The larger radius does a better job distributing the stresses from the stringer onto the hull and reduces the chances of hard spots, which can cause concentrated stresses. We've waited a little over an hour now, and the thickened epoxy is kind of gelled up enough so we can actually glass over top of it. In this location right here on the frame, it's kind of hard with this wood jig to get in and tab it all in. So we'll just worry about doing the center section, but I'll put a layer of release fabric on it. So after I get the jig out and then wait till tomorrow, I'll pull the release fabric and then I'll tab that all in. So we'll get started here. I have a decent amount of epoxy all mixed up, ready to go. From my fiberglass tabbing, I cut 3 layers of 17-ounce fiberglass that were 9 inches wide. The first layer was applied over the fillet for the hull joint so that the fiberglass extended 3 inches up onto the stringer and 6 inches onto the hull. The second layer was staggered so it had 4 inches onto the stringer and 5 inches on the hull. The third layer was 5 inches onto the stringer and 4 inches onto the hull. By staggering the layers by an inch like this, you get a more gradual transition of the stresses from the stringer onto the hull. I started on the inboard side of the stringer, then repeated the process on the outboard side. For the frame, it was a very similar process. Here, instead of laying the fiberglass tabbing as one continuous strip, I cut it in the middle so it would conform to the V of the hull easier. For simplicity's sake, I fiberglass over the top of the limber holes and will drill them out after the epoxy cured. This way, the fiberglass reinforcement continues right up to the edge of the hole. For tabbing the frame to the stringer, I again followed basically the same process. The gap between them was filled with thickened epoxy earlier, which supported the fiberglass. Here, however, the first layer was centered over the fillet and the two remaining layers were offset by about an inch either direction. One thing to note is that as I'm building up these layers of fiberglass, I'm slowly reducing the amount of space between the stringer and in the corners. This is a good thing to be aware of as you're doing a repair in case, for example, your fuel tank is a tight fit. On the back side of the frame, the jig got in the way. I decided to tab just the middle area to support the frame and do the outer edges once the epoxy had cured and the frame could be removed. On these outer areas, I applied release fabric so I didn't have to come back and sand again. Now I'm only putting release fabric in these areas, but of course you could put the release fabric over the entire area. When you remove the release fabric, you also remove the amine blush, so your surfaces are already prepared and ready for bilge paint. The next day, I tabbed the outer edges of our frame. I thickened my epoxy with 406 colloidal silica and filled the screw holes we had used to attach our stringer and frame to the jig. So this project may seem intimidating for a first-time do-it-yourselfer, but really it's not as challenging as it may seem. If you kind of go through the same steps that I kind of went through, it is actually very simple, but it does take a lot of hands-on effort. But if you do have any questions, feel free to reach out to us either by phone or visiting our website at westsystem.com. Thank you for watching. Bye.